right, so this is your assignment for October 29th. You're going to end up doing about 8 of the problems here. We're going to do 3 of them together. Questions 1, 3, and 7 we're going to do together. And at the end of the day, you only have 5 that you need to complete by yourself. So when you look here at number 1, we have our coefficients that have been written in red. And you have 2 different sides. You have your arrow in the middle and your left side, which are referred to as reactants, and your right side, which is referred to as products. And just like in your previous assignment, you want to make sure that the left box equals the right box. The only difference is you don't have the molecules drawn out for you this time. We're going to have to look at this more mathematically. So what we're going to do, we're just going to move the coefficients first. And we're going to kind of compare what we have starting off. If you look on both sides, you have nitrogen and hydrogen. Those are your 2 main elements right now, nitrogen and hydrogen. And starting off on your reactant side, you have 2 nitrogens. If we look here on the reactant side, we have just 1. So we're going to increase our number of nitrogens by adding another molecule. So this means that we're going to have to put our coefficient of 2 in front, because that means that we will now have 2 molecules of NH3. Mathematically, this also means that we have 2 nitrogens. And unfortunately, as a consequence of the distributive property, we will now have 6 hydrogens as well. So if we look at our left side, on our reactant side, we see only 2 hydrogens. Well, we want both sides to match. So product side or right side has 6. Left side or our reactant side only has 2. So we can increase and add our molecules together to get a total of 3. Or we can think of this mathematically and say, what times 2 will give me 6? And we would know that the answer is 3, because 3 times 2 is 6. And so then we would have the correct number of hydrogens and the correct number of nitrogens. If you're not having to bother with any of your coefficients, then that means that you have just 1. So let's go ahead and look at numbers 3 and 7 on a regular sheet of paper. And for this assignment, I don't mind if you write it out on a piece of paper. I don't mind if you complete it in Kami. However you want to complete the assignments are completely fine, because this right here, as long as I see that you are going through the process to get the correct answers, that's what matters. So if we look at number 3, this is where we have sodium chloride, NaCl, plus fluorine, and that will give us NaF, sodium fluoride, and chlorine, Cl2. And so again, I'm going to go ahead and give these to you. Your left side is called your reactant side. Your right side of the arrow is going to be called your product side. You're going to either look at this and say Na is good, Cl, I'm missing 1, so I'm going to say what times 1 can give me 2, and I would just put the number 2 here and know that 2 and 2, it matches. Or we can do a different way. And if you're more mathematical, this way may make more sense. But if you're good visually, continue to do this visually. That's completely fine. I'm just showing a different method. So in this other method, we're going to look at our left side, our reactant side. So we have an R. Your elemental atoms which that's our A. And we know that we have Na, Cl, and F. Those are our 3 different elements. And last but not least, we have our right side, our product side. And so that gives us an RAP table, or RAP table. And again, this is kind of looking on both sides. I have 1 sodium on both sides. Reactant side, I have 1 chlorine. Product side, I have 2. Fluorine is next. I have 1 fluorine on my product side and 2 on my reactant side. And I can look. Sodium looks good at first glance. Chlorine, I know that this side needs to have 2, so I'm going to increase my number of molecules. And then I'm going to apply my coefficient. So 2 times 1 gives me 2 sodium, and again 2 times 1 gives me 2 chlorine. So now my chlorines match, but my sodium is off. So I'm going to increase my number of molecules over here. I'm going to put a second molecule of NaF. And again, it is a coefficient, so it's multiplied out. So 2 times 1 is 2, and again, 2 times 1 is 2. And I'm going to double check. 2 and 2, sodium is good now. So let's check out fluorines. Let's see what happened here. 2 and 2. So they actually balanced out whenever I was balancing out sodium. So that works out perfectly. So I didn't mess with these two, so I'm going to keep my number 1 because there's still at least 1 there. Even if there's not a number, we have to have the understanding that there is 1. All right, let's go and look at number 7. Number 7 was CH4 plus O2 and CO2 and H2O. All right, this one's a little bit more tricky. The difference is I have 2 oxygens by themselves on my reactant side, and on my right side I have 2 different oxygens in 2 different places. So the plus is going to mean I'm going to add them together. So 2 plus 1, overall I have 3 oxygens on my product side. So I can do this 2 different ways. I can do this visually, looking back and forth and putting in my coefficients, or I can do this with the RAP table. And your RAP tables, again, reactant side is your left side, product side is your right side. I have to identify my elements and look at what I'm starting with. Carbon, I have 1 on my reactant and 1 on my product. Hydrogen, I have 4 on my reactant and 2 on my product. Oxygens, I have 2 on my reactant and 3 on my product. So carbons are good starting off. I'm not going to mess with them. Hydrogens, I'm going to look at these and I'm going to say, okay, I have 4 on my product, or 4 on my reactant side over here. I need to try to get up to 4, or at least find a common ground. But I see that I have 2. If I increase my number of water molecules, I know that 2 times 2 is 4. And again, since your coefficient goes out to everything, I now have 2 hydrogens coming from your water. So 2 plus 2 is 4 oxygens. So looking at hydrogens again, 4 and 4, they match. They're good to go. Carbons are still looking good, so we're going to say they're good to go. Only thing left is my oxygens. Oxygens, 4 on my product, 2 on my reactant. They still don't match. So I'm going to increase my number of oxygen molecules on my reactant side. I'm going to increase it to 2 because you have to go up step by step. So 2 as a coefficient, 2 times 2 gives us 4. And if we look 4 and 4, it's good to go. So our final coefficients will be 1, 2, 1, 2. So when you write this out, I don't mind if you write it out kind of like how we have in Kami for number 1. You can kind of go either one of these. It doesn't really matter to me. Or you can kind of work these out on a piece of paper, take a picture of them, and turn them in this way. I'm not really too much of a stickler when it comes to that. As long as I see that you're attempting the work and you have your coefficients filled in. So with that said, I want to kind of address some problems we normally see every year. Some students who aren't fully able to understand this, they like to try and just complete the work without asking questions, and they just try to get a completion grade. And so what they'll do is they'll assume I'm just putting random numbers places, and they'll just put in 1, 3, 2, 1. And that's completely wrong. Please don't be one of those students who just randomly puts in numbers. This is your basic for chemistry. Balancing equations tells you that matter cannot be destroyed or created. It is simply reused. That is what balancing an equation actually tells us. So when you do this, that's completely disregarding that law. And that law is what you learned back in middle school. And so please don't do this. This is incorrect. That is not what you're supposed to do. And balancing equations can be very difficult. So please make sure that you approach this with some patience and care, and please don't get easily frustrated. I know it's really difficult, especially if you don't understand something, but 100%, it just takes some time and some practice. So make sure you ask questions when you don't understand. So I'm going to go ahead and also attach a Khan Academy video to kind of help better your understanding, because I know sometimes as a teacher that it may sound better or it may make more sense when it comes from somebody else. So if there are any other questions with the assignment today, please make sure to ask, and I do hope that you'll have a wonderful weekend.